Alright, while we're in this chapter working with proportions, one thing that fits in here is more of a geometry concept, but the math behind it comes from this algebra. So we have two similar shapes. Similar shapes means, you can take one shape and, let me grab a shape. Here, you can take one shape, so there's one. Similar shape to this would be if you were to take it, let me clone it real quick, so here's another one. Right now they're exactly the same. For it to be similar instead of exactly the same, it just means that it is, oops, there we go. You just take your shape and you make it bigger or you make it smaller. But what you notice is all of the angles, so you can see that angle in the corner, all the angles are still the same. It's just the sides are different shaped, but they all are proportionate or proportional to each other. So that's the idea of similar shapes. And the statement up here, this is a similarity statement. This is the key to everything. This will help us figure out our missing value of x. You can see we have x over here. We didn't know what it is. Well, the fact that these two triangles are similar, we can set up a proportion and solve. So, what I do on these, and I highly recommend everyone do this, is figure out which sides go together. And I go back to the similarity statement. I go in order. First, I'm going to find side AB, because those are the first two letters on the left. So side AB is this side between the A and the B, and I'm just going to put one mark. Now I want to find its matching side in the other triangle, so I go to my similarity statement and I look at the first two letters, DE. So AB will be similar to DE. So I find DE on the right, I'm just going to put one mark. So I know those two are similar to each other. Well, I want to match up all three sides, so I have to keep going. I go back to my similarity statement and I look at the next two letters. I've got BC. So I find BC in my triangle. I'm just going to give 2 marks just to make it different. And then I back at my similarity statement. I know it's going to match up with the next two letters, EF. So I find EF over here on the right. I'm going to give it its 2 marks, and I know those two sides would match up. Now, we only have one side left in each triangle, so I know that that one would get 3 and this one would get 3. So what I want to do is set up a proportion using sides that go together. For example, you can see this 8 feet gets matched up with this x. So let's do that. I'll put 8 over x. Now, in my proportion, we're going to set it equal to another fraction. I'm just going to make a note that this is the small triangle on top and the large triangle on the bottom, and I'm going to match that information on the right. So what number should I use for the right? I'm looking for another pair of sides to match up. Now if you notice, we actually have some extra information that we don't need. Do you guys see this 12 feet right here? That is one with 3 marks. If I go to my 3 marks on the right, that's this side, but do you see how we don't know how long that is? That means that I don't even want to use that 12 feet because I don't have a number on the right to match it up with. So that's an extra piece of information I might accidentally use if I'm not being careful. So in my small triangle, I got my 5 feet with the 2 marks. So I'll put the 5 on top because I'm putting small triangle information on top. Now I look for the side that goes with it with the 2 marks, and I see the 20 feet. That's from the large triangle, so I'm going to put 20 down here with my large triangle information. That's the hard part. If you guys can do that, then you just cross multiply and solve, and then you're done with the problem. So just make sure you get this set up. That's the focus. Can we set up a proportion? Blah. Can I say proportion? And then you just multiply your diagonals. 5 times x is 5x. 8 times 20 is 160. and then divide both sides by 5. 160 divided by 5, we get x equals 32. And do these have labels? Oh yeah, it all looks like everything is in feet, so 32 feet. So by using similar sides that are proportional to each other, I know that that x side is 32 feet long.